Every hard coding problem breaks down the same way. Let's learn how. In this course, we're covering how to actually solve problems, not just memorize solutions. Understand what's being asked, then break it into smaller pieces. Spot the pattern hiding underneath, and the code almost writes itself. We'll cover 2 pointers, sliding window, hash maps, recursion, and backtracking, sorting and greedy, and graph traversal. Most mistakes happen before you write a single line of code. For coding anything, you need to fully understand what's being asked. Start with this checklist. First, what exactly is the input? Its type, its size, its type. Second, what is the output supposed to be? Be precise about the exact format expected. Then check the constraints and the edge cases. Empty input, huge values, duplicates, negative numbers. Most mistakes happen here in understanding, not in the coding itself. Big problems become easy once you break them into small ones. Large problems are solved by splitting them into smaller parts. Instead of tackling something vague like, build a system, break it into input handling, processing logic, and output formatting. This is called decomposition, and it's the single habit that makes hard problems feel manageable. 2 pointers can find 2 numbers that sum to a target in just one pass. Place 2 pointers at the ends. Their sum is 9. Too low. So we move the left pointer right. Now the sum is 11. Too high, so we move the right pointer left. Still too low, so move left again to 4. Now we have exactly 10. That's our pair. One pass, no extra memory, the power of 2 pointers. What if you didn't need 2 loops to scan every subarray? A sliding window keeps a running range of elements, and instead of rechecking everything, it just adjusts the edges. To move right, subtract the element, leaving the window, and add the one entering it. One operation, not a full rescan. For a variable size window, grow it by moving the right edge while your condition isn't met yet. Once it's satisfied, shrink from the left to look for a smaller valid window, keeping track of the best one seen. One pass, O of n. Sliding window turns nested loops into a single sweep. How do you check if you've seen something before? Instantly. A hash map stores key-value pairs so you can look anything up in constant time. No searching required. 4. Frequency counting. Walk the input once and increment each item's count in the map as you go. Need to know if something's already appeared? Check the map. One lookup, not a second loop. This turns an O of n squared brute force scan into O of n. The map remembers so you don't have to search again. What if a function could solve a problem by calling itself? Recursion solves a problem by breaking it into a smaller version of the same problem until it hits a base case. Every recursive call needs a base case, the smallest input it can answer directly without calling itself again. Backtracking explores those choices one at a time, and the moment a path can't work, it undoes the last step and tries another. It's exploring, not guessing blindly. Every dead end teaches it to backtrack and try the next option. Recursion breaks a problem down. Backtracking searches every path and undoes the ones that fail. Some problems get easy the moment you sort them first. Sorting first often reveals the structure. A problem is hiding, neighbors become comparable, and patterns emerge. A greedy approach then picks the best local choice at each step without ever looking back. It works when a locally best choice always leads to a globally best answer, which is exactly what a good sort sets up. Sort to expose the structure, then greedily commit to each best choice. No backtracking needed. How do you visit every connected node without getting lost? A graph is just nodes connected by edges, and traversing it means visiting every reachable node exactly once. Breadth's first search explores level by level using a queue. It finds the shortest path in an unweighted graph. Depth first search dives down one path as far as it can, using a stack, then backtracks when it hits a dead end. Either way, mark nodes as visited, so you never process the same one twice. That's what keeps it from looping forever. Same graph. Two strategies, BFS for shortest paths, DFS for exploring everything a path can reach. You now have the toolkit, 2 pointers, sliding window, hash maps, recursion and backtracking, sorting and greedy, and graph traversal. If this helped, drop a like and subscribe for more. And the fastest way to get better is to practice these patterns yourself. See you in the next one.